Section 4 of Constructive Beekeeping. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Van Lance, Woodstock, Alabama. Constructive Beekeeping by Ed Clark. Section 4. Condensation. A good understanding of the condensating properties of a hive will make clear a great deal that puzzles us about bees, and such knowledge constructively applied to honey production cannot fail to give results, the magnitude of which the beekeeper with his present knowledge would hardly dare to hope for. We have seen that ventilation by moving the warm air out of the hive reduces the heat of the hive. When better results can be obtained in a way that conserves the heat of the hive, a step forward has been taken. This will result if we let the bees, as they are striving to do, use their hive as a condenser. To understand how water vapor is condensed in a hive, the dew point should be understood. Saturated air is at the dew point. The amount of moisture that the air will hold varies as the temperature changes. The amount of moisture in the air is spoken of as absolute humidity. Air at 0 degrees Fahrenheit is saturated with half grain, at 60 degrees Fahrenheit 5 grains, and at 80 degrees Fahrenheit with 11 grains of water vapor. Air at 60 degrees, which contains but 2.5 grains of water vapor, would be at half or 50% of saturation. Air at 78 degrees, which contains the same amount of water vapor, 2.5 grains, but would be a quarter or 25% saturated. This percent of saturation is called relative humidity. If the amount of water vapor in the air remains constant as the temperature changes, the relative humidity changes with the temperature. Air that is saturated at 78 degrees would have to give up 50% of its water vapor when its temperature is reduced to 60 degrees, leaving this 60-degree air also saturated. The dew point is the temperature of the air at which it would be at saturation if the amount of moisture is neither increased nor diminished. To illustrate the principle of the air giving up part of its water vapor when its temperature is reduced to the dew point, saturate a sponge with water, then press on it lightly and it loses part of its water. The pressure of the hands acts on the sponge the same as reduced temperature on saturated air. The most obvious illustration of this formation of dew, or condensation of moisture on a cool surface, is when a pitcher of ice water is placed in a warm room. This everybody is familiar with. Condensed vapor on the windows when the outside temperature is cool is another. Place a pan, bottom up on the ground, and dew will be found on the inside surface of the pan in the morning. The beehive, when we allow the bees to arrange their own ventilation, condenses vapor this way when there is enough difference between outside and inside temperature to give a dew point on the inside surface of the hive. We do not observe any great amount of moisture on the inside walls of the hive during the urge period because the bees, needing a good supply of water to mix with the food they prepare, gather it as soon as it's deposited, leaving the surface in better condition for more condensation. This gives the bees nice distilled water for their use. Records of weights taken in morning and evening during the honey flow show but a slight loss in weight of the hive each morning. This has puzzled many beekeepers, and some have suggested that the bees got rid of the water of the nectar before entering the hive. Let us look at this and apply this condensation theory. The bees evaporate the water from the nectar, condense it on the inside walls of the hive, then gather it as distilled water and mix it with food for the brood. The water has been evaporated, but the hive still retains it, and the hive weights have decreased but little during the night. We have all had some experience with dew and have observed that all objects will not have dew on their surface in the morning, after a night favorable for the deposit of dew. The grass will be very wet, but the road is dry. A painted board is wetter than an unpainted one. The grass and the road are in contact with the air containing the same amount of water vapor. Any natural philosophy will explain this by the laws governing the radiation of heat. The surfaces of objects on which the dew has been deposited radiate more heat into space, and consequently cool more than the ones that radiate less heat and have no dew on them. The air which comes in contact with a colder surface, and whose temperature is reduced to the dew point, is compelled to give up some of its moisture. The law of the dew point operates in the hive the same as the outside. Air in the hive at a temperature of 90 degrees, which contains 8 grains of water vapor, must, when it comes in contact with cooler walls of the hive whose temperature is 60 degrees, give up 3 grains of its water vapor. This condensation will go on as long as the temperature of the hive walls, temperature of air in the hive, and humidity of hive air hold such relations to each other that the dew point obtains at the inside surface of the hive. All objects do not radiate heat equally well. Some part with their heat or become cold faster than others. A smooth stone, exposed the same as grass surrounding it, does not part with its heat as readily as the grass. Propolis. Blackened tin has a high radiating power and is taken as the standard for expressing the radiating power of other substances. Give the radiating power of blackened tin as 100. Rosin is 96, and wood is very low. Propolis being a rosin, its radiating power is almost perfect. But few substances approach this high standard. It is obvious that more condensation takes place on hive lined with propolis than one where the wood is without a varnish. More condensation makes more evaporation, more expiration makes more room. A substance like propolis, that is a good radiator and absorber, is a poor transmitter of heat. Propolis used as a varnish keeps the hive heat from warming the wooden walls, and they being cooler at night, give a temperature to the inside surface that condenses the water vapor fast or slow as the difference of inside air temperature and wall temperature is great or small. The bees, finding it necessary to separate a great deal of water from the nectar, dispose of it by evaporation. But instinct tells them that the air holds very little on cool nights in May and June. So to remove this moisture from the air, they varnish the inside walls and make a condenser out of the hive. The process is, in principle, the same as that used in distillation. The makers of refrigerators take advantage of condensation to maintain dry air in the food chamber. A refrigerator car, after years of experimenting, has been finished off with several coats of varnish. It has been proven by tests that products that are inclined to sweat or absorb moisture keep drier in a highly varnished car than in one not varnished. The water vapor in the air condenses on the inner surface of the car, making the air drier, consequently preventing the absorption of water from the air by the product stored in the car. Shade. Shade in the afternoon has been observed to have a tendency to prevent swarming.